Hello and welcome to this technical walkthrough of my Wildfire Risk Predictor project. This project comprises of a machine learning model that predicts wildfire hazard risk by combining satellite imagery analysis with geospatial data. This project's key innovation is in its two-head model pipeline, in which the first model is a binary classifier that predicts the probability of fire ignition, and the second one is a regression model that predicts the conditional log burned area given that the ignition occurs. These two predicted values are then multiplied together to produce the final hazard risk score. Both of these models are implemented as XGBoost models. And these XGBoost models are fed with CNN embeddings from a pre-trained ResNet 50 CNN model, along with multimodal geospatial features, all extracted from the Wildfire Spread TS dataset. So the first part of the pipeline for the data processing is extracting the CNN embeddings. These embeddings are produced from a pre-trained ResNet 50 model using transfer learning, and we can extract 2048 dimensional embeddings. These embeddings are then stored in a paraquet file in the data interim folder. These CNN embeddings are then combined with the geospatial features from the dataset, and the geotiff files are read to extract the ground truth labels, which are the ignition, which is a binary indicator, and the burned area. The combined output is then stored in the data processed folder as features CSV. And this processed data is then randomly split 70% into the training, 15% into validation, and 15% into testing. I then train the models with reweighting, L2 regularization, and early stopping. I also use GPU acceleration. I then combine the predictions of both models to compute the final hazard score. And then I evaluated the models with evaluate both models .py. With the binary classifier, I used evaluation metrics such as the ROC curve and the precision recall curve, and I used accuracy as well. For the regression model, I used the root mean squared error, the mean absolute error, the R squared value, and Spearman correlation. Then I produced the visualizations for the evaluation metrics in the Python notebook called Visualize Evaluation Metrics. And for the P model, I plotted the ROC curve and the precision recall curve along with the confusion matrix. For the A model, I plotted the regression lines for the log burn area and for the burn area in the original scale of hectares. Then for the combined model of the prediction of the hazard risk score, I again plotted the regression line for this model and also a residual plot. The most substantial challenges to this project was the multimodal format of the dataset, making it difficult to process into the training data. Another challenge was getting the regression model to accurately predict the total amount of burned area. This could be due to the stochastic qualities of climate and meteorological conditions. The main technical contributions from this project include the two-head architecture of my model, the transfer learning from the ResNet 50 CNN to extract feature embeddings, and the multimodal feature engineering that came from the multimodal geospatial features in the wildfire spread dataset. And finally, the ability to support fire departments in deploying resources efficiently, reducing response times, and allowing more preparation time before a wildfire could start. Thank you for tuning in to this technical walkthrough of my project.